Welcome to this deep dive. We're looking into the sources you shared with us, exploring the really fascinating and complex world of multi-agent systems in AI.
It really is a big shift, isn't it? We're
Yeah.
sort of moving past this idea of AI as just one giant all-knowing model
Yeah,
and
exactly.
starting to look at it more like teams,
Yeah,
multiple AIs working together, like a digital ecosystem.
absolutely. And the material you sent, it really zeroes in on Anthropic's multi-agent research system as a key example here.
Right.
So our mission today is to, well, unpack what these sources reveal. How are these systems being built? What are the big opportunities and maybe the significant hurdles too?
Yeah, because understanding this, it's not just about the tech specs. It's about grasping a fundamental evolution that's happening in AI right now.
And why it matters.
And why it matters for how we'll tackle those really messy, complex problems down the line.
Okay, so let's dig into that Anthropic system the sources describe. A key thing seems to be this orchestrator-worker pattern. It's not like one AI does everything. Instead, you have this lead researcher agent.
Right, it goes into this extended thinking mode just to plan the work.
Ah, okay. And then it delegates specific tasks out to multiple specialized subagents.
Exactly, and they can work in parallel.
Which gets to the why, I suppose. The sources are pretty clear on the why behind this architecture.
Yeah, it seems specifically designed to overcome limitations you see in single large language models. Things like struggling with information compression, hitting those token limits.
Right, the practical limits.
So by having these subagents focus and kind of condense their findings, they can collectively process vastly more information than one agent could alone.
And the sources, they show this isn't just theoretical, right? They're using it for pretty demanding knowledge work.
Oh yeah, things like developing software, generating technical content, figuring out business strategy.
It seems to really shine on those breadth-first queries, where you need to explore lots of different angles simultaneously.
That's what they say. And the performance boost compared to single agents for those kinds of tasks is apparently pretty significant, according to the sources.
Okay, but building these systems sounds, well, complex.
Definitely. And the sources highlight sophisticated prompt engineering as like a primary way they manage that complexity.
So it's about carefully crafting the instructions.
Yeah, almost like teaching the agents not just what to do, but how to behave like good collaborators, how to research effectively, even how to critique their own work.
Which brings up a huge engineering challenge and another key point from the sources. How do you even debug something this dynamic?
Good question. Traditional methods probably fall flat.
Right. The sources emphasize something called full production tracing.
Which sounds like logging the agent's decisions and interactions. Not the content itself, but the pathways, the patterns.
And that trace is presented as absolutely crucial for figuring out what went wrong when something breaks.
Makes sense. They also mentioned building in state management so the system can, handle errors and pick up where it left off.
Now, if we step back a bit, the sources show Anthropic's coordinated specialists model. It's just one way to do it. It leans towards maybe control and reliability, like a tightly managed team.
Yeah, but it's not the only game in town. OpenAI, according to the sources, seems more focused on giving developers a flexible toolkit of capabilities.
And suggesting different patterns, like handoff collaboration.
Right, kind of betting on the broader ecosystem to innovate with those tools.
And DeepMind is mentioned too, taking maybe a fundamentally different route, their socio-computational research.
Yeah, they seem to be using multi-agent reinforcement learning in simulations to study the science of interaction itself.
Like cooperation, emergent social dynamics.
Exactly, exploring the foundational principles.
It's clear, though, none of this just appeared. The sources trace this work back decades, right? Academic research, game theory, multi-agent reinforcement learning.
Oh, absolutely. There's a long history there, understanding how agents behave when everyone's changing the environment for everyone else.
And now researchers are kind of synthesizing the raw power of today's LLMs with those classical frameworks.
Exactly. The challenge has really shifted, it seems, from just figuring out the mechanism for agents to interact, to defining the content, deciding what instructions to give them, how to define their roles effectively.
But okay, with all this power and complexity comes risk. The sources are pretty clear on that.
Yeah, they point to universal engineering hurdles. Complexity explodes as you add agents, scaling is tough, and debugging unpredictable emergent behavior sounds like a real nightmare.
Which leads straight into the safety concerns highlighted. The sources even offer, taxonomies for how these systems can fail.
And it's not just simple bugs. It's systemic risks like miscoordination or actual conflict between agents or even unintended collusion.
There are also risks mentioned about how data gets used or amplified, and the huge challenge of accountability when a complex system causes harm.
It really underscores that the safety challenge isn't just aligning one AI anymore. It's about designing effective systems, maybe even robust societies of agents.
Which implies thinking about governance and oversight, not just code.
That seems to be the takeaway. Looking ahead, the sources paint a pretty clear picture. We're moving towards interconnected AI ecosystems.
Enterprises might start with more controlled systems.
Right, but the future likely involves agents from different places needing to interact reliably.
And the path forward, according to the sources, involves things like targeted research, building fundamental infrastructure. They even mention needing something like an agent identity and verification system.
And crucially, prioritizing observability, that tracing we talked about. You need to see what's happening.
The ultimate vision hinted at is maybe a kind of human swarm synergy, humans and AI teams collaborating.
Yeah, the research frontier seems to be shifting towards understanding this new form of cooperative intelligence.
So, wrapping up, the sources you shared show us that AI is fundamentally evolving. It's moving from single entities to these complex, interacting digital ecosystems.
hmm The power from this collaboration is huge, but it's definitely tangled up with more complexity, unpredictability, and serious risks like agents miscoordinating or even conflicting.
And managing this shift really requires sophisticated design, careful instruction that prompt engineering and deep visibility into what the system is actually doing.
So the big challenge now isn't just building smarter agents, it's designing effective systems and even the basic structures for these interacting digital societies.
Which leaves us with this thought for you, the listener, to consider. If the future inevitably involves these vast ecosystems of interacting AI agents, what are the fundamental rules, the norms, maybe even the laws we need to start thinking about and establishing now?
To ensure these digital societies are safe, beneficial, and, truly aligned with human values.
Thank you for bringing these fascinating sources to our attention. This was a really insightful deep dive.